This is Design Safe Radio, where natural hazards researchers strive to make our society more resilient to everything nature throws at us.
You are working on some really important things, with the cone penetration test, as well as remediating these liquefaction-prone soils I'm learning about out here now, living in the Pacific Northwest. Can you tell us a little bit about the project that you've got behind you? If people are watching on YouTube, you've got a really great field rig there. Tell us a little bit about that. I've got a couple of follow-ups in here, but we'll start there.
Yeah. So this project, it started in 2019 to do two field trials, actually, of microbially induced desaturation, MID, with the idea that, and this was really spearheaded by folks at Arizona State University, that if you can desaturate the soil, induce desaturation in it, then now the soil is much less prone to liquefaction and liquefaction triggering. So at ASU, they started looking into how can we leverage microbes in the soil to perform a denitrification reaction that produces nitrogen gas that desaturates the soil.
So desaturating being lowering the water content.
Yeah, exactly. So the microbes, they burp out nitrogen gas and maybe a bit of carbon dioxide, and that gas stays in the soil structure and it displaces the water in the soil. So that now this gas is taking the place of some of the water, and it acts as kind of a cushion during earthquake shaking. And so, these denitrifying microbes, denitrifying bacteria, they're pretty prolific. I mean, they seem to be in most soils. You don't need to necessarily cultivate them. They're native to most soils or naturally occurring soils. And so at our site in 2019, we actually at our two sites, one of them that's behind me, we set up an injection system and a way to extract water. And from that extracted water, we mixed a treatment solution, injected that treatment solution into the ground, and then that treatment solution stimulates the microbes that are in the ground to produce that nitrogen gas and desaturate the soil. So we did it at two sites in 2019. The site behind me, the one out near the Portland airport, we've had ongoing access to it. I was out there last night for the last 5 years, and we have it for we have another project. So we have it for the length of that project at least. And we can look and monitor and see how the gas in the ground is changing, if it's lasting, if the ground is starting to resaturate, if we need to retreat it. So we're able to look at all those questions that are really important to the application of the treatment method. Wow.
There's a lot to unpack there. So we got the site that's kind of ongoing at the airport. What other sites are you looking at?
So there was another site that we treated in Northwest Portland, the industrial area, which won't mean much to anyone, but it was at the border of what we call in Oregon the critical energy infrastructure hub, which is really, there's a river that runs through Portland called the Willamette River, and there's an industrial area along the Willamette, which is
kind of funny because it also runs through Eugene.
Right, yes.
It goes all the way from where I live all the way up to you.
All the way to Portland, and then it meets the Columbia. Yeah. And this industrial area was largely developed, it's a lot of river deposited soils and a lot of fill, like hydraulic fill from the river as they dredged the river and started to build up historic lakes and build out the shoreline a little bit and raise up that low lying ground. I'm going to
see if I can share a screen here for those who are watching on YouTube. If this will work.
So any geotechs or geologists that are listening will kind of think, oh, river deposited soils and hydraulic fill, that's a real liquefaction hazard. And then on top of that, we have a lot of fuel tanks that are located along the river there. Something like 90% of Oregon's soil or Oregon's fuel is liquid fuel. It passes through the critical energy infrastructure hub. Whoa. And so if you turn it on to satellite view.
Oh yeah, let's do that. There we go.
And then pull the map just so we can see a little bit to the south. You've got most of the area shown here.
4.
Yeah. So on the other bank of the Willamette River, you can see all of those fuel tanks. Let me see if I can
Oh, it's
annotate.
all these guys.
Yeah, all those fuel tanks.
Whoa. Yeah.
So lots and lots of fuel tanks along the river on soils that are considered pretty liquefiable or have a high liquefaction hazard. And so there's an understandable concern that during a strong earthquake, like what we're expecting or what we know will happen at some point in the future, that there will be damage to these fuel tanks. The fuel will spill into the river. It may combust. So we have potentially like a hazard to the populations around these fuel tanks. There's communities next door to them.
Yeah,
Environmental
you've got
hazard,
these,
hazard to the
communities right
fisheries.
across the highway from there.
Yeah, yeah. And and then also just a loss of Oregon's fuel supply. Like I said, something like 90% of Oregon's liquid fuel passes through or is handled through the critical energy infrastructure hub because we don't have refineries. So from all aspects, from an economic, from a health, from an environmental, and then from just a resilience recovery aspect, this is a major hazard for Oregon. So what I'm getting at is that this, oh, and I mean, the other part of it is that a lot of these fuel tanks were built before we had an understanding of the seismic hazard in Oregon. And I think
Of
they
course
might
they were.
also predate seismic standards as well. Like I think the average age is something like in the 40s or 50s. So, so yeah. So there needs to be something done about these tanks, and there is legislation in Oregon that's mandating seismic vulnerability assessments and then eventually retrofits at these facilities. But so what prompted us, going back to the original question, is we performed a trial of microbially induced desaturation at a site at the north end of the critical energy infrastructure hub to see well, we had access to the site and also to say, like, can we successfully apply microbially induced desaturation at a site in the critical energy infrastructure hub to see if it's a potentially a mitigation method, a viable mitigation method for some of these fuel tanks. And so, yeah, the site, if you just keep going a little north, yeah, there it is. So that gravel pad just south out of frame in the photo, just to the south. Yeah. So that's a Portland General Electric facility there.
Oh,
We did the field trial just to the side of it. I'm trying to see if I can annotate, but yeah, so we did the field trial where you see the waterway and all those fallen logs just kind of to the northwest of that site. That's where we did the field trial, and then about a year after we performed it, there's the annotation.
there we go.
Yeah, so this is where we had performed the field trial in 2019, and then in about the year following it, they turned it into, and we knew this from the beginning, it was turned into like an environmental restoration project for a fish waterway. So,
Great.
so yeah, so with the field trial, we saw that we could successfully desaturate the soils in the CEI hub or just adjacent to the CEI hub. But unfortunately, we didn't get to spend the time going out there in the years following to see if the desaturation lasted.
Yeah, but a good first step, and as you said, a critically important piece of mitigation to be done, while we're waiting for the who knows how long it's going to take to get retrofits to all these tanks. I mean, there's tens of them. There's lots of them to do. So it's not going to happen overnight. And if there is some way to at least mitigate some of the impact of the soil from a minimally invasive method, like injecting a solution into the soil around it, that sounds like a huge win.
Yeah, because I guess this method also, it has the plus of being that, like you said, minimally invasive or destructive, because a lot of these tanks are old and relatively fragile.
Yeah.
And so doing a method like jet grouting or like deep soil mixing might be too disruptive to the tanks themselves. Whereas this one is, I mean, you almost don't even realize it's happening when you're performing the treatment.
Yeah, I'm speculating here, but it sounds almost like it's not a huge cost either, as much as grouting would be or something like that.
Yeah, and yeah, you're kind of leading down the path of like our colleagues at Arizona State University, along with the contractor that was a huge help in performing these field trials, Conan Johnson and Associates. We wouldn't have been able to do the field trials without them. But so the two of them together did an economic assessment comparing jet grouting underneath an existing structure to microbially induced desaturation underneath an existing structure. And I think it's like a third the price based on their estimates of using MID versus jet grouting.
That's amazing. So what's next for this research?
So we're continuing to go out to the field site to take data to understand what is the distribution of the gas currently, to get an idea of like, where does it go and how long will it last? And then the other part of it is how effective is it for fine-grained soils?
Right.
If we know that it suppresses liquefaction triggering, does it also suppress the hazards that come from liquefaction triggering, like the ground deformation, settlement, lateral spread? Are those also equally suppressed as well, or mitigated? So that's where the research stands right now. We're tackling it in the lab and then also with this field work, and in collaboration with folks at Arizona State University and also at University of Maine, where at University of Maine, they have a lot of knowledge on like gas, water transport, gas, water transport through soil. So they're really critical.
I would not have expected that from Maine, but go University of Maine.
Yeah.
Cool. Yeah, that is a really interesting point of, it's great if we can desaturate the soil, but if it doesn't actually mitigate the effects, then it's, what's the point? So yeah, that's a really great next step, and looking forward to seeing some of the results as they come out. Yeah. This has been a fascinating discussion, as I knew it would be. You see people talking about microbially induced soils and cone penetration tests, and unless you're in the NARI network, you're like, well, that's not going to be interesting. But I knew this was going to be great. So it's been a pleasure to chat with you today. Where can people follow along with your research as you start getting into your career proposal and all the other things that you're working on?
Sure. So I guess there's my website. I don't know. You can find it by Googling. My name is unique enough that you can find it. I don't know the address at the moment, but I'll update it with publications or projects and some project photos as they come in. And then our graduate students, as part of establishing this chapter, they've also developed their website and put up their website. So you can see our students and the work that they're doing, and outreach events or presentations they're giving. And so that's a great way to keep up with our group as well.
Fantastic. Well, yeah, keep up the great work. And thank you for keeping the fueling infrastructure of our state, beginning to mitigate that, because we know that someday it's really going to need it. So yeah, from all of us down here in Eugene, we appreciate it. It has been really wonderful chatting, and we'll have to come up and see your lab someday. That'd be really fun.
Yeah, anytime.
Thanks for listening to today's episode of Design Safe Radio. Be sure to like and subscribe on whatever platform you happen to be listening to this on. It really helps people find our show. Thanks to our amazing sponsors, the National Science Foundation and the NARI Network Coordination Office, which is award number 2129782. Big thank you to Marty LaChance, our guest booker and topic researcher extraordinaire, and Raquel Ruiz, who is our video and audio editor. I'm your host and NARI Facility Scheduling and Operations Coordinator, Dan Zahner. We'll see you in the next episode. Until then, stay resilient.